Good morning, boys and girls, and I wanted to say hi to everyone. Judith wanted to say hi. She was going to try to behave herself this morning, and we hope that you enjoy today's math lesson. Oh, there she is already. she's always ready to go for your math lesson. Judith, are you going to behave yourself? Hi. Say hi to everybody. Say hi. There you go. All right, so we're going to get started. Jude is waiting for the mailman, so she'll probably be a little bit loud here in a couple minutes. So I hope you guys have been having a great couple of days. We're going to get started on our 12.8 math lesson. We are problem solving. We are classifying plane figures. Remember plane. Okay, so we are back. I had a little bit of technical problems. So we are starting right here. All right. Okay, so technical problems are under control. We are going to go to problem solving, classifying plane shapes. Remember, plane shapes can be opened or closed, and they can have curved sides. Also, you can have polygons that are different than plane shapes. Polygons have to be closed, and they have line segments that connect. So we want to just make sure that we're constantly remembering the difference between plane figures, plane shapes, and polygons. All right, so we're going to get started here. And it says, a Venn diagram shows how sets of things are related. In the Venn diagram at the right, one circle has shapes that are rectangles. Shapes that are rhombuses are in the other circle. The shapes in this section where the circles overlap, that's where both the rectangles and rhombuses, what they have in common. Now, we've done Venn diagrams. We know that Venn diagrams are comparing and contrasting. So over here are rectangles, and they are contrasting over here, which means they're what's different than rhombuses. Rhombuses over here, this is what they're contrasting, their differences. Where they overlap in the center, that's the compare. That's what they share, what they have in common. So it says, what do I need to find? So hopefully you're reading the problem and you're seeing that you need to find out what type of quadrilaterals are in both circles. And then what information do I need to use? Well, when you look at it, the circles are labeled rectangles and rhombuses. So you know that you are going to be using all of this information up here on rectangles and rhombuses. Then your next question down below, which I can't see on my screen, but you have in front of you, how will I use the information? So you go back up, you reread it, and you think to yourself, okay, I'm going to describe the shapes in the section where the circles overlap by their sides and angles so I can name the shapes. So remember, we're looking at rectangles and rhombuses, so we need to look at their angles. We need to look at do they have acute angles? Do they have obtuse angles? Do they have right angles? Do they have parallel lines? How many sides are parallel? Do they have equal sides? So then you go over and you look at solving the problem. What is true about all quadrilaterals? So you think to yourself, what is the definition of a quadrilateral? Well, they have to have 4 sides and 4 angles. That's it. Then what quadrilaterals always have 2 pairs of opposite sides that are parallel? So you know if you go up here, opposite sides are parallel. This is a rhombus, its opposite sides are parallel. You go here, this is a square, its opposite sides are parallel. And you go over here and you see this has a rectangle, has opposite sides are parallel. So you write down rectangle, rhombus, and squares. And then it says which quadrilaterals always have 4 sides of equal length. You know that squares and rhombuses have to have 4 sides that are equal length. And then which quadrilaterals always have 4 right angles? You go right up top, you see rectangles and squares have 4 right angles. I'm going to scroll down and it says the quadrilaterals in the section where the circles overlap always have 2, and you can see that if you go up to your overlapping, 2 pairs of opposite sides that are parallel, 4 sides of equal length, and 4 right angles. So both in that circle are squares. All right, so we're going to go on and we're going to move on to our next page. I hope everyone's on the next page, and it says try another problem. So we have another Venn diagram here. We have quadrilaterals on this side, and we just did the definition of quadrilaterals. Then over here we have polygons, which are closed shapes with no curved sides that have right angles. So these have right angles, and they're polygons. Polygons means they could have many sides that are closed. Over here, quadrilaterals. Quadrilaterals means you can only have 4 sides. And then where they go in between, these have to be quadrilaterals and they have to have right angles. Okay? So it says, where would the shape shown below be placed in a Venn diagram? Well, 1, 2, 3, 4. It has 4 sides and it has a right angle. So this is a trapezoid, and trapezoids would go right in the center. Okay? All right, so to figure that out, what did you need to find? Well, you need to find out where it would be placed in the Venn diagram. What information do I need to use? We talked about that. It has to have quadrilateral and it has to have a right angle. How do you use the information? Well, you know you're looking for a 2-dimensional shape and you're looking for where you would place it. How many shapes do not have right angles? So we have to go back up, find some that don't have a right angle. So how many shapes do not have right angles? So if you look here, these have lots of angles, but no right angles. They have probably acute angles and maybe an obtuse angle. Right here, this doesn't have a right angle. And right here, this doesn't have a right angle. This trapezoid has obtuse and acute. So we have 3 that do not have right angles. How many red shapes have right angles but are not quadrilaterals? How many red shapes? So we go up here and we want to know how many have right angles but are not quadrilaterals. Well, this has 4 sides, so it's a quadrilateral. This has 4 sides, so it's a quadrilateral. It has 4 sides, it's a quadrilateral. So we go over to this red shape. It is not a quadrilateral, so it falls into that category that it has a right angle right here in this corner, but it is a triangle, and it is a right triangle. And then your last question, what are some different ways to sort shapes? Well, you can sort them by if they have parallel lines. You can sort them if they are polygons. You can sort them if they have right angles. So there's lots of different ways that you can sort different shapes. So we're going to go to our share and show. Okay, so we are back. We did the share and show. We learned more about Venn diagrams and how to use them to classify our different shapes, to sort them into the different areas that they would go. So now we are going to be on page 743, and we are going to be using this Venn diagram for questions 1, 2, and 3. Jordan is sorting the shapes at the right in a Venn diagram. Where does the looks like a diamond. Where does the diamond go? So we want to figure out where we're putting something. Okay? So it says first look at the sides and angles of the polygon. So these are all polygons. They're all closed-sided figures that have 3 or more sides to make them closed, and they They have no curved edges. Next, draw the polygons in the diagram, in the Venn diagram. The shape has blank sides of equal length and blank right angles. So the shape goes in the, so we're looking for, does this have how many sides that are equal? So it looks like 4 equal sides, so it's actually not a diamond, it's a rhombus. And then, so it has 4 equal sides, and then how many right angles? So if we look at it, none of these are right angles. So it has 0 right angles. So the shape goes in. So it says polygon with right angles, and then polygons with all equal sides. So we know it has all equal sides, but it has no right angles. So it has to go over here. Okay. So then where would this go? And this is a trapezoid. It has 4 sides. It does have right angles. So a polygon with right angles, polygon with all sides that are equal length. Well, we can see that that side is not equal, so it would not go over here. It would stay in the polygons with the right angles. Okay, so why don't you go through and take these and draw a line to where you think they would go. So just take a moment. So I have mine, so this guy right here, he is a polygon with right angles, so he goes here. And all sides of equal length, it can't go because it is a rectangle. So let's do our next color. So right here, polygon with a right angle, all lengths are the same, and we see that these have different lengths, so it's going to go right here. Hopefully you guys are drawing yours. So we're sorting number 3, we're sorting them to the correct one. So let's do another color. So we have 1, 2, 3 sides. There are no right angles, but it is an equilateral triangle. All the sides are the same, so it has equal lengths. 1, 2, 3, 4, 5. It has right angles. So right angles, polygon with all sides equal. No, it does not have all sides that are equal though. But it does have right angles. 1, 2, 3, 4. All sides are equal. They have right angles, so it goes right in the center. 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. They do not have all sides the same length, but they do have right angles. So choose red. This guy's going to go over here, and we're down to our last 2. 1, 2. These 2 right here. 1, 2, 3, 4. All sides are the same. It has right angles. So this square goes right in the center. And then our last one, 1, 2, 3, 4, 5. It's a pentagon. It does have all sides that are the same length, but it does not have any right angles. So it goes over here. So mine are a mess because I was not drawing them. Hopefully yours looks nice, neat, and you drew some nice pictures there. So we're going to go a little deeper. Eva, she drew the Venn diagram below. Write labels that she could use for her Venn diagram. So now she already has them all organized. Now you have to decide what is the left side and what is the right side. So if you look at these, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So they all have how many sides? 4 sides is correct. And let's look at these. Parallel, parallel, parallel. So they do have some parallel sides. So we could say quadrilaterals over here with one set of parallel lines. over here on our right-hand side, we have 1, 2, 3. So that's a triangle. 1, 2, 3, 4. So that has 4 sides. So we could say, oh, and if you look right here, that's a right angle, and that's a right angle. So these could be polygons with right angles. And then these have right angles, and they're a polygon. And they're quadrilateral, quadrilateral, quadrilateral. So they still fit in this one. And these have right angles, and so it would fit in the right-hand side. So this one could be quadrilaterals, parallel sides, and these could be polygons with right angles. Ooh, that's kind of cool. You really had to think about that one. So this is on your own. So I'm going to let you take a little time. I want you to read the on your own, and I also want you to do the practice and homework and the lesson check. And then you're going to come back and I'm going to give you the answers. So pause the video and then come right back. All right. So hopefully you're back, and we are going to look at Ben and Marta are both reading the same book. Ben has read 1/3 of the book, whereas Marta has read 1/4 of the book. They want to know who has read more. So hopefully you remember, the bigger the denominator, the smaller the piece. The smaller the denominator, the bigger the piece. So think of a candy bar. Do you want to share a candy bar with 3 people or 4 people? If you share with 3 people, you get a bigger piece. If you share with 4 people, you get a smaller piece. So you can tell then that Ben has read more because he would have the bigger piece. Represent a problem. There are 42 students from 6 different classes in the school spelling bee. Each class has the same number of students in the spelling bee. So if it's the same number, hopefully you're thinking equally divided or put together. So you're either thinking multiplication or division, repeated. It's the same number. Each class has the same number of students in the spelling bee. Use the bar model to find how many students from each class. Well, we know there's a total of 42. We know there are 6 different classes, so we're going to equally divide 42 into 6 different classrooms. So hopefully you've been practicing your multiplication. That's part of your job every day, to practice your spelling and your multiplication. So you're ready for 4th grade. So we have 42 divided by 6 gives you 7. So 42 divided by 6 gives you 7. All right. We're going to go on to number 7, and it says draw and label a Venn diagram to show one way you can sort a rectangle, a square, a trapezoid, and a rhombus. Well, we know that they all have 4 sides, correct? Okay, so you want to have a drawing and see how you could do that. So maybe you want to use 4 sides. You can have where you have right angles. These have right angles. These have the same side, the same size, just like a square. The sides are the same. Ashley is making a quilt with squares of fabric. There are 9 rows and 8 squares in each row. How many squares of fabric are there? Okay, so you know there are 9 rows. So in every single row, so you have 9 rows, there are 8. So that's repeated addition. 8, 8, 8, 8, 8, 8, 8, 8, 8. So you do, hopefully you did 9 times 8 and you got 72 squares. Remember, multiplication, you're going to be using it. Make sure you're practicing. Question number 9. Sketch where to place these shapes in the Venn diagram. So polygons with all sides that are equal, so all sides that are equal, all sides that are equal. Quadrilaterals with right angles, quad, 4 sides. So hopefully you see where you would put these, and hopefully you see that the Triangle goes here, equal sides, it's an equilateral triangle. And this one also, the square has all sides that are equal, so it would go here because it's a quadrilateral and it has right angles, so it would go right in the center. It shares those qualifications. On your practice and homework. All right, hopefully for number 1, they did for you A, B, E, and C, D, which they did for you. So then you're going down here to number 2, and you were taking these shapes and putting them where they belong. And hopefully on your answer for polygons with right angles, you put A, B, and C. And then where it shares right angles and equal length, you had D, which was your square. For number 3, you had to draw a Venn diagram with one circle labeled quadrilaterals, all 4 sides, and the other is a polygon with at least a right angle, and then draw 2 shapes. Hopefully you did that, and then you explained why you drew those shapes. So your lesson check, number 1, it would be right here. What shape could go in both sections where they overlap, and hopefully you figured out a square. Number 2, a quadrilateral that could not go and labeled with all sides equal. Well, hopefully you saw that that was a trapezoid. Your spiral review, how many angles greater than a right angle does this one have? And hopefully you saw 1, because this is an acute, this is an acute, and this is an obtuse, which is greater than a right angle. How many sides of equal length does this triangle appear to have? Hopefully you see that it has 3, and it is called an equilateral triangle. Number 5 and 6, Madison drew the shape. How many angles less than a right angle does it have? Hopefully you see 0. These are all obtuse angles. They are all greater than. And then how many dots are in 1/2 of this? So if you would break it right in half, you would see that if you drew a line right here, there's half here and half here. And so you would have 9 on this side and 9 on this side. All right. I hope you enjoyed your math lesson today. Judith and I look forward to seeing you tomorrow, and we actually miss seeing you each and every day. So take care, be safe, and I'll see you tomorrow.